Good morning, student. Let us solve some problems related with a excitation energies and wavelength of series of spectral line. Okay, see this first problem. Determine the energies of the first two excited states of the electron in hydrogen atom. First, we have to find out E2 and E3. Because the first two excited state is nothing but n is equal to the 2. Therefore, corresponding energy is E2. And next one is n is equal to 3. Therefore, corresponding energy is E3. Therefore, first we have to calculate E2 and E3. Then, what are the excitation energies of the electron in these orbit? Then we have to find out the excitation energy. You know the excitation energy is the difference between the energies of electron in that state and the energy of the electron in the ground state. Therefore, E2 for excitation state, okay, and again we have to calculate E3 for excitation state, okay. Therefore, we have to calculate these two quantity also, okay. Then you know that the energy of the electron in nth orbit is given by En is equal to the minus 13.6 upon n square in electron volt. Okay. Then we calculate the value of E2. E2 is equal to the minus 13.6 upon 2 square is equal to the 4. Therefore, it becomes as 4. This becomes 3 with minus sign 0.4 electron volt. Okay, now next E3. E3 is equal to the minus 13.6 upon n square is 3 square. Therefore, it becomes 9. Therefore, minus 13.6 upon 9, it becomes minus 1.51 electron volt. These are nothing but energies of electron in second orbit as well as in third orbit. Okay, this is minus 3.4 electron volt and this is minus 1.51 electron volt. Now we calculate the excitation energies of the electron in these orbits. First, we calculate the excitation energies for the second orbit. Okay, therefore, E2 for excitation energy, we can say that is equal to the, what is that value? Is minus 3.4 minus ground state energy is minus 13.6 electron volt. Therefore, this becomes minus 3.4 plus 13.6 and this becomes the 10.02 electron volt. This is the excitation energy for the second orbit. Okay. Okay. Therefore, we calculate this is 10.02 electron volt. Now, excitation energy for the third orbit. Okay. Excitation energy. It is equal to the, it is the difference between the energy of the electron in that state, means third E3, okay, and the energy of the electron in ground state. What is the E3? E3 is minus 1.51 minus ground state energy is minus 13.6. Therefore, this becomes minus 1.51 plus 13.6, and this becomes as it is 12.09 electron volt. Therefore, these are the values of energies of the first two excited state of the electrons. Okay, and then excitation energies of the electron are nothing but a 10.02 electron volt and 12.09 electron volt. Okay, now next problem. Calculate the wavelength of first three lines in Pachan series of hydrogen atom. Specifically, we have to calculate the wavelength of first three lines, means we have to calculate in solution, we have to calculate lambda 1, lambda 2 and lambda 3. Okay, given quantities is nothing but a RH, means Raybert constant is 1.097 into 10 raised to 7 meter inverse. Okay, then which formula is used? 1 upon lambda 1 is equal to the RH 1 upon P square minus 1 upon N square. Okay, for Pachan series, what is P? P is equal to the 3 and N is equal to the 4 for first line. Okay, therefore 1 upon lambda 1 is equal to the 1.097 into 10 raised to 7, 1 upon 3 square minus 1 upon 4 square. Therefore, 1 upon lambda 1 is equal to the 1.097 into 10 raised to 7. Okay, this is 4 square means 16. 16 minus 9 upon 9 into 16. Okay, therefore 1 upon lambda 1 is equal to the 1.097 into 10 raised to 7 into this is 7 upon this multiplication is 144. Okay, therefore 1 upon lambda 1 is equal to the, this is multiplication 1.097 into 7 is 7.679 upon 144 into this is 10 raised to 7. Okay, now then lambda 1 is equal to the, what is the value of lambda 1? Lambda 1 is equal to the 144 upon 7.679 into 10 raised to 7. Okay, if you calculate this 144 upon 7.679, then this becomes lambda 1 is equal to the 18.75 into this is 10 raised to minus 7 meter. This is the wavelength of first line in Pachan series. Similarly, you can calculate the wavelength of second line. 1 upon lambda 2 is equal to the 1.097 into 10 raised to 7, 1 upon 3 square minus 1 upon 5 square. Because for second line, what is the value of P? P is equal to 3. Okay, inner orbit is fixed orbit, but N is equal to the 5. And then you can calculate, you get the answer, lambda 2 is equal to the 12.82 into 10 raised to minus 7 meter. This is the lambda 1, this is the lambda 2. Similarly, you can calculate the lambda 3, that is the wavelength of third line in Pachan series. For the third line in Pachan series, n is equal to the 6 and p is equal to the 3. Okay, then we get lambda 3 is equal to the 10.94 into 10 raised to minus 7 meter. These are the values of wavelength of first 3 lines in Pachan series. You should know which are the values of P and N in Pachan series in these problems. Okay, now next problem, problem number 3. It is very important. Calculate series limit of Balmer series. Okay, then given lambda L is equal to the 912 Armstrong. Okay, now solution. In this problem, we have to calculate the series limit of Balmer series. Then what is the series limit? Series limit means the smallest wavelength emitted in that series is called as the series limit. What is the series limit? It is the smallest wavelength emitted in that particular series. The series limit of a particular series can be calculated or can be obtained by taking n is equal to the infinity. This is very important point. There are the two wavelengths, shortest wavelength and longest wavelength. जसं इथं आपण longest wavelength घेतली, n ची पुढची व्हॅल्यू घेतली. ओके, p जर 3 असेल तर n काय घेतला आपण 4 मिळायचं. ह्याला लॉंगेस्ट वेव्हलेंथ म्हणायचं. शॉर्टेस्ट वेव्हलेंथ म्हणजे किंवा सिरीज लिमिट म्हणजे तर the smallest wavelength emitted in particular series is called as a series limit and then can be obtained by taking n is equal to the infinity. आता here we have given the lambda L means wavelength of Lemon series. Okay, and we have to calculate the series limit of a Balmer series. Okay, then first formula, the series limit of Lemon series is 1 upon lambda L is equal to the RH 1 upon P square minus 1 upon N square. Therefore, 1 upon lambda L is equal to the RH 1 upon Lemon series is the first series 1 square minus 1 upon infinity square. Okay, therefore this implies that 1 upon lambda L is equal to the RH, say equation number 1. Here we take the n is equal to the infinity. Okay, कारण आपल्याला लेमन सीरीजचे वेवलेंथ दिलेली होती, मग आपण त्याच्या सीरीज लिमिट साठी लिहिले इक्वेशन्स. नाउ वी हॅव टू कॅल्क्युलेट द series limit for Balmer series. Now the series limit for Balmer series is as 1 upon lambda B for Balmer is equal to the RH 1 upon P square minus 1 upon N square. For Balmer series, what is the value of P? P is equal to the 2 and n is equal to the infinity. Therefore, 1 upon lambda b is equal to the RH 1 upon 2 square minus 1 upon infinity square. Okay, therefore, it becomes 1 upon lambda b is equal to the RH upon 4. This is equation number 2. Okay, simply we get 1 upon lambda is equal to the RH, 1 upon lambda b is equal to the RH upon 4. And now we have to calculate the series limit of Balmer series. Therefore, our aim is we have to calculate the lambda b. Okay, we have to calculate the value of lambda b. Okay, therefore, equation 1 upon equation 2 gives equation 1 upon equation 2 gives as lambda b upon lambda L is equal to the 4 series. 1 upon lambda L into lambda b upon 1. Therefore, we get lambda b upon lambda L. Okay. On this side, this is the RH get cancelled and this becomes the numerator. Therefore, we get the 4. Okay. Therefore, lambda b is equal to the 4 into lambda L. Therefore, 4 into lambda L is 912. Therefore, this becomes 4 into 2 is 8. 4 into 1 is 4 and 4 into 9 is 36. Therefore, 3648 Armstrong. Okay, lambda L is given in Armstrong, not necessary to calculate in meter or centimeter, because we have given the lambda L in Armstrong and we have to calculate the lambda b. Okay, and therefore same physical quantities आपल्याला calculate करायची होती. Therefore, not necessary to convert it. Therefore, we get the answer lambda b is equal to the 3648 Armstrong. Okay, in this way you can calculate the series limit of any series. Fund series, Beckett series, Lemon series, and also the Pachan series. Okay, let us stop here.